Welcome to this tutorial. I'm solving question number 10 of paper 2-1 May-June exam series of 2023. The topic of this question is the nuclear atom and the half-life. Question says carbon-14 is an isotope of carbon. It undergoes radioactive decay with a half-life of 6,000 years. The age of a sample of wood is found using carbon-14 that it contains. Part A. Describe what happens during radioactive decay. So, during radioactive decay, emission from the nucleus occurs of an alpha particle or beta particle or gamma radiation. So, when at least one of them is emitted from the nucleus, this is called radioactive decay. The count rate of carbon-14 in a sample wood is initially 1600 counts per minute. So this is the initial count rate. Figure 10.1, draw a graph to show how the count rate will vary over the next 24,000 years. The initial count rate is already marked with an X. So since the half-life is 6,000 years, so the count rate is going to half every 6,000 years. So after the 6,000 years, there would be a count rate of 800, which when marked on the graph would be marked here at 6,000 years. Then after further 6,000 years, we have the value of 400 at 12,000 years. Then after further 6,000 years, the value would be 200, and similarly after further 6,000 years the value would be 100, so it would be marked here. Now if we draw the curve, so this is how the decay curve would be formed using this data. Okay, the next part says name the apparatus used to measure the radiation from the sample of wood and describe how it is used to measure the count rate. So the apparatus used would be a GM Geiger Miller tube, a rate meter, and a timer. How the apparatus is used? So we make the measurement of the number of counts in a specified time. For example, we could measure it every 1 minute. Then subtract the value of background radiation from it to find the corrected value of the radiation for the carbon. Now the next part says describe how the count rate from a sample of wood is used to find its age. So first of all, we measure count rate of similar mass of fresh wood and then we use the graph to find the age of a sample of food as per the value of the count obtained from the sample. So this comparison gives us how much period or the time has passed for this sample, and its age is found in this way. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.